This is a past paper pop quiz 5. Figure 6.2 shows a ray of a green light passing into or through and out of the glass prism. So this is a green light, okay? A ray of a blue light. Remember, we have the violet, indigo, blue, green, yellow, orange, and red. The violet bends the most and red bends the least. So this is green. The green light is there. We want to make blue. Blue will bend more or less. Blue
Yes.
will violet bends the most and red bends the least. This is green light is shown here. We want to make blue. So blue will bend more or less? More. So if you want to show it will bend more, so that will be the path of the blue light. The same way it will enter, but it will bend more. If it was a violet, it will bend further from like greatest. And if it was a red light, then it will bend the least. So on a figure, draw the path of a blue light through the prism. Then figure 6.1 shows a converging lens, an object OX, and the focuses of the lens are labeled F. On a figure, carefully draw. Look, in the first part, it is about the electromagnetic spectrum, the bending. If the prism was placed like this, and we have a violet, indigo, blue, green, yellow, orange, and red, so violet was bending the most and red bends the least. So what we did, we just flipped the prism. The prism is up other way. And we have the same white light. So in this case, the violet bends the most and red bends the least. So this one, green light is given, like green will be in between. So green light is given. They are saying the path for a blue. So we have violet, indigo, blue, green, yellow, orange, and red. So green light is given. What will the blue one? So the blue will bend more than green. So we want to show the path of a blue, so we should show more bending, greater bending, a greater change in the speed. That is what we are supposed to do. Figure 6.1 shows Figure 6.1 shows a converging lens, an object OX and the focuses. On the figure, carefully draw the two rays from X and locate the image of an object. And measure the distance IY and the principal axis to the center line of a lens. So first we have to draw, so first parallel light ray, from where it should pass through. A parallel light ray.
Focus. Focus.
Good. So it will pass through focus. One through the center of the lens. So from where it will pass through? It will pass straight without any change. These two light rays will never meet. So what we will do, we will produce them backward. So when we produce them backward, this is a position of the image which will, and image we call IY. So we call that as an image. So that is IY. And we need measure a distance from IY along the principal axis to the center of the lens. So this what you have to do, you have to use a scale, a ruler, and measure a distance between the image and the center of the lens using a ruler. Okay. That is you're supposed to measure by using a scale according to the figure. State two reasons why the image is virtual. Some student wrote image is virtual because it is not real. That does not make sense. Like if I say why it is daytime, you will say it's day because it's not night. That is not the reason for that. So what are the points you should always mention whenever it's a virtual image? First thing, rays will not meet after refraction. And the second point,
Image formed
Image,
by
yeah, image formed same site as object, or you can also say image not forming on screen. If the image was forming on the screen, then it will be a real image. So real image formed by a convex lens are always inverted. Virtual images are always upright. Another similar question. Figure 6.1 shows a full-scale diagram of a converging lens and the two focuses. On a figure, draw two rays to determine the position of image. So first, here, first a parallel from where it will pass through. It will
focus.
pass through focus. One through the center. From where it will pass? It will pass straight. What will happen? Will these light rays meet? No. And it is obvious that the object is between the focus and the lens, so it will not form a real image. So what we'll do? We'll produce it backward. The two light rays, we produce them backward, and this will be the position of image, which we also call that as IJ. And measure the length of image. You want to measure a length of image. So again, using a ruler as scale, measure the length of this image. But length will vary according to the scale in terms of the print, because it should be done on the printed paper. So length will vary. It will not have a fixed length. Ring three descriptions of the image. What are the description of this image when you see?
Magnified.
It is magnified is one. Is it diminished? No. Is it real? No.
No.
Is it same size? No.
No.
Same way up as object? Yes.
Yes.
Because yeah, upright or same way. Upside down? No. Is it virtual? Yes, it is virtual.
How much points in this search? How much I get?
What?
How much I get in this chapter? Out of it. Maybe it's longer.
Not that long. The next is figure 6.2 shows the three rays of a green light which is passing through the block. These are the green lights.
Right.
The three rays of a red light approaches a glass block, same path as a ray of a green. Figure 6.2 draw the path of these rays. Okay, here. This is a green light. We want to make a path for a red. Red will bend more or less?
Less.
Less.
It's the distance.
So for the first one, for the prism on the top, we want to make. So for the prism on the top, it will be above like this. For the prism at the bottom, it will also bend less. But for a glass block, it will go so because it is passing along the normal. So if it is passing along the normal, it will pass straight, irrespective of what kind of ray. So red will bends the least, violet bends the most. That's how you complete these parts. Okay, so this was the past paper pop quiz.
Yes, sir.